question number 5. It says chlorine gas is bubbled into a solution containing sodium bromide. Okay, the reaction is written here. So you have chlorine gas. This is the solution. So you have a solution of NaBr. You know its solution because it's written aqueous here. And if you have a tube, you can bubble the chlorine gas here into this solution. So when you bubble the chlorine into the solution, look what happens. This chlorine replaces the bromide here. So it forms NaCl and the bromine comes out of the compound. It becomes Br2. The equation is given to you. It says the equation for the reaction is, so the equation is given to you. Okay, just let me. Okay, so part A says chlorine takes the place of the bromine in the metal compound. What is this type of the reaction called? Okay, what is the name of this reaction? When one thing replaces the other atom in the compound, it has a special name. What is the name of the reaction? Anyone knows? Okay, so this reaction is called single displacement reaction. Okay, so a single displacement reaction is a reaction that one atom replaces another atom in the compound. Cl2 as a gas, sodium bromide. So what happens here? The chlorine replaces the bromine. So you have uncombined atom replaces another atom in the compound, in the NaCl. So the product would be NaCl and bromine comes out of the solution, Br2. This type of the reaction is called single displacement reaction. Okay, so it's very obvious. When one atom replaces another atom in the compound, we call it single displacement reaction. Okay, so part B of this question says the compounds of group 1 metals are white and give the colorless solutions. What would you see as the above reaction proceeds? What can you see here? It means, okay, NaBr is colorless solution. So these solutions that you have here is colorless. Okay. When you bubble the Cl2, what's producing here in this compound? Br2 is producing here. So after bubbling chlorine, you have a lot of Br2 here. Br2 has a brown color. So what can you see after the bubbling Cl2 inside this colorless solution? You can see this color of the solution turns brown. Okay, so you will see brown color after bubbling Cl2 into this solution, because what forms in the product is Br2. Okay, so this is what you see in this reaction. In part C says write a half equation for the reactions of the chlorine. Is the chlorine oxidized or reduced in this reaction? And half a right equation for the reaction of the bromide ion. Cl2 reacts with NaBr. It converts to NaCl plus Br2. So let's identify the oxidation half equation and the reduction half equation. When you have the ionic compound, it's better to separate them to the cation and anion. So I separate it to Na plus and bromide, and sodium chloride I separate it to the sodium ion and chloride ion. So it makes it easier to identify which one is oxidized and which one is reduced. So you can see the Cl2 here becomes negative. It means the Cl2 is reduced. So this is reduction. And what happens to the Br minus? Br minus is converted to Br2. It has lost the electron. So this process is oxidation, and Br2 is oxidized. Now I write these two half equations. Half equations. Let's write first oxidation half equation. Okay, in oxidation half equation, Br minus is converted to Br2. And in reduction half equation, what happens? Cl2 is converted to Cl minus. Now I need to balance these two equations. So for balancing the first one, I need to put 2 here and 2 electron at the other side. For balancing second equation, I need to put 2 for chloride to make same as the other side, and 2 electrons here. Okay, so now the number of the electrons are equal. I can add these two equations to get the redox equation. So the redox equation would be 2Br minus plus Cl2. It gives you Br2 plus 2Cl minus. So we identified in these reactions which species is reduced, which one is oxidized, and we wrote oxidation and reduction half equations, and finally we wrote the redox equation. In the part E, at the beginning, it gives you some information. It says reactive elements have a stronger tendency to exit as ions. Which is more reactive, chlorine or bromine? So let's come back to these equations that we have here. Okay, look at this redox equation. So which one is more reactive? Cl or Br, chlorine or bromine? Look what it says you in the question. It says the reactive elements have a strong tendency to exist as ion. So the element which is more reactive converts to the ion. So here, what is finally converts to the ion in the product side? Cl minus becomes ion. So this shows that chlorine is more reactive. So Cl is more reactive than Br. Why it's more reactive? Because they can react with each other, and finally the chlorine becomes the ion. If the bromine was more reactive, than chlorine, this reaction could not take place. Okay, because the more reactive ion remains in the ionic format. But because here the chlorine is more reactive than bromine, the chlorine converts to the ion, and bromine is in uncharged format. So now we can understand that the chlorine is more reactive than the bromine. So this is very important point. Okay, so when you want to know which element is more reactive when you are comparing the non-metal, you must look at the product side. The non-metal which becomes negative or which becomes the ion, it is more reactive. So as you can see here on the product side, you can see finally chlorine becomes ion, but the bromine is not ion. This shows that the chlorine is more reactive than bromine.